I will report our recent activities of the first Chinese Earth orientation parameter prediction comparison campaign. So I'm the speaker from National Time Survey Center of Chinese Academic Sciences. And also we have many contributors to this talk. I list the names below. Okay. So I will start my talk from 5 points. Firstly, I will give the motivation of the campaign of the first CEO PPC, and then is an overview. And thirdly, I will quickly show some technical details on the prediction method currently is the submission used. And fourthly, I will evaluate our half-year submissions. And lastly, I will show some prospects for our candidate and for future EOP predictions. So, okay. So let me go. So the motivation. So last summer, we hold a seminar in China in July named EOP Forecasting and Earth Rotation Changes in the AI area. And this figures shows the photos. And at that moment, we have around more than 70 researchers and students joining this seminar, and from more than 20 institutes or universities. We contribute more than 30 talks, and at that moment, I think Justina and Soja and also Sadiha, you also contribute 3 talks at that seminar. And in that seminar, we noticed the quickly progress of the AI techniques in the scientific research, and we discussed the possibility of organizing a similar campaign like the second EOPPC, but in China. Yeah. That's the background and motivation. And this slide shows the aims. I think the aim should be nearly similar to the second EOPPC. Firstly, we want to promote communication and collaboration between researchers and maybe also students. And we think we should share experience on the AI and machine learning techniques. In many researchers and students, they want to learn the new techniques. And thirdly, I think such activities are very good for training and education because for our campaigns, most of them are undergraduate students. And fourthly, we want to find the best method or algorithm on EOP prediction. So this is the motivation. And then I will give some overview information of the first CEO PPCC. So we start from last September, and we plan to have 2 years. And here we show is the submission rules. So every week, Wednesday, UTC 20. So the deadline is same to the second EOPPC, and we can accept the submissions by email or by FTP. So yeah. So this is the submission rules. Next, I show the currently we received 11 submissions from 6 institutes and university. So this page shows the submission for population predictions. So from 6 institutes and university, the first one is from the Shandong University of Scientific and Technology, and also from Information Engineering University, and from Lanzhou Jiaotong University, from Sun Yat-sen University, and from National Time Survey Center. And lastly, is from the Institute of Geographical Science and Natural Resources of CES. So 6 submissions from 6 institutes and university for population prediction. And then is the UT1 IOD. We got 3 submissions from Shandong University of Science and Technology, yeah, and from National Time Center, 2 submissions. And we also have 2 submissions for the celestial pulse set, all of them from our team. Yeah. So this is the submissions summary. Next page, I show the submission from last year September to last week. Yeah. 2 submissions is from the item number 211 is from end of last year. So and the last submission is just submitted from last month. Yeah. And this page shows some. We form a support team. Some people from NTIC and from Shandong University for Science and Technology. We have people maintain the servers for collections, and we have 3 sub-evaluation groups. Each group have 2 people. They will confirm with each other to make sure the evaluation is consistent. And finally, we have some feedback to make sure they can update their code or some prediction method. And we plan to hold some workshops, maybe half a year or like this. And finally, after the 2 years campaign, we hope we can make some publications. Yeah. So this page shows the first workshop we held end of last year. Yes, in our institute. So here I should say thank you to all the participants and also to contributors. Then I move to the prediction method sessions. So here I will show some methods. Most of them are from the workshops, their slide. Okay, I go ahead. The first one is ID 202. They make polar motion predictions. The method uses LS plus machine learning, and they use a denoised EM dataset. And the right panel show what they derive the denoised EM dataset. I didn't have time to give more details, but I give the reference below. Yeah. So to reference, and Xi Shunli from our team, he developed an algorithm to, yeah. Later I will show some slide to show, yeah. Anyway, they use machine learning to predict the random noise, and also for the EM data, we make some operation of the GFZ EM dataset to make sure they have a better performance. And this slide shows the predictions of their submissions. So the red line is their prediction, and the blue line is measurement. Yeah, we just evaluated this week. The next page shows the prediction of these IDs, their polar motion Y component. So, the next ID is 203. They also make polar motion predictions. They use machine learning method with a tool like Informer, and they use nearly all the EOP parameters they can get as inputs, and then they predict the polar motion components. This page is their submissions and compared with measurement for PMX and PMY. For this submission, we found the first 2 months their performance looks not so good, but they seem improved their code, and from the 3rd month, their performance getting better. And then this is the third submission for the polar motion. And they use multi-variable singular spectrum analysis method, and the left panel show the paragraph what they did. They first fit the linear train and then use MSSA to find the frequency component, I think, and then they predict the each components and then combine them. And the right panel shows the correlation of the reconstructed components. This is some slide I got from their workshop. They split the, yeah, I think they also show the spectrum of each component. Yeah, so to make sure they are meaningful physically. And then is predictions. And for these submissions, they firstly submit 2004 based on the AER 20 series. And this is PMX and this is PMY. I think the performance looks good. Yeah. But recently, the submission was based on the 14 series. Yeah. So we will evaluate both of them. So next submission is also a machine learning for the polar motion. And they use the least square method to fit the make a least square fitting for the residual. They use like hybrid machine learning method. They use like the GIU and the linear neural network, and they use at least three machine learning algorithm and combine all of them to yeah, and then I will show the result of the submissions. And this submission, they submit every week. So yeah, this is very good. I think it's only the 1 week looks not so good. Apart this one, the upper right panel, that week looks not so good. After that, all other submission looks very good. And so this is a PMI component. Okay, so this is another submissions for the polar motion. So from Dr. Li Xishun. So okay, so this is also polar motion, but he didn't submit papers. So I just put here the paper is for UT1 and LD, but to show the what he did actually. So actually he fit the GM and also he fit the EM, and he found the residues of these two totally independent methods. The residue actually is highly correlated, and we assume that the residues have information is not well modeled geophysical information, and we assume that the left panel accuracy is better than the right panel, and just replace the residue and then recover a better EM dataset. So he just published the paper submit last year. Okay. So I will show their submissions, each submissions, and the performance looks look good. It's for PMX and PMY. Okay, so next is also a prediction for polar motions from the ID is 211. So he also show what they did. He used 3 different machine learning algorithm, and lower panels they use SIA to split the to lower frequency component and high frequency component, and then predict each component independently, and then combine them to. So actually they tried six method and find the best one from these. And the pictures is also they show their evaluations in the workshop. And here show is their submission. They submit their prediction from the end of last year. Okay. So then I move to the prediction of UT1 IoT. So for the UT1 IoT prediction, we have 3 submissions. The first one is from our undergraduate student Zhang Lulu. So she, I think this method is developed based on the method from Dio's 2019 papers. So because we use EM dataset, we followed the algorithm. And here he used STM to replace the AR for the random component. Now others, I think is nearly similar to the Dio's method, but use LSM to replace the AR method. So here shows is the comparison of the prediction and measurement for LD, and it seems that this sometimes it works, but sometimes it doesn't work. Sometimes it seems some like shift. I don't, yeah. And also here is the UT1. The performance looks not so good for this submission. Yeah. Next one is I will show the 2 submissions altogether because they actually from the same team, similar. So first is ID 207 is actually use the same code of ID 101 in the second UPPC. Yeah. And the ID 206 is the algorithm involved from the ID 207. The only difference is they use the denoised EM dataset. And below the figure that I have shown, and make explanations and show the reference. We just replace the residuals from with the GM as fitting residue to replace the EM residue, and to form a new EM dataset. And here shows a prediction of the LOD, so it looks very good. Yeah. And also, so this is a original version. So it looks similar, a little bit different. And also, this is 206 UT1 prediction, and 207 UT1 predictions. These 2, I think is highly correlated, but later I will show the MAE result of these 2. So finally, here is the prediction for the celestial power offset dx and dy. So currently we have only 2 submissions, and the ID 214 is just updated from last month. So at that moment, currently we cannot evaluate this. So for the celestial power set, we only have one submission can be evaluated currently. So here we show their evaluations. I think we use only 2 periods for the 1 year period and 433 days period, and use the LS plus AR method. So we found it seems that currently the method we use cannot modeling the high frequency component. Yeah. So then I move to the next session. We will evaluate all of these submissions altogether to show compare different submission. So this page shows the 6 submissions for polar motion X. Yeah. Generally speaking, the team 2 and team 8 they have all submissions. And for the team 4, they submit both the 20 C04 series and 14 to C04 series. So we evaluated separately. So yeah. So that is the final MAE figures for the polar motion component for all these submissions. Okay, I think within 10 days, seems the ID should be 210 is better, and after 10 days, the team 2 have the best performance. Yeah, I give the MAE in statistics of tables below. Then I move to the evaluation of the half year for the polar motion X component. The team 3, they seem to have some problem for at the first month. The performance was not so good, but later they improved. And for yeah, okay, this figure shows the MAE on all these submissions. Again, the team 3, the performance is not so good, but we found maybe they use because even the 0 days they have a very large offset. Yeah. Okay, so then I move to the evaluation for the LOD and UT1. So for LOD and UT1, we have 3 submissions with ID 201 and 206 and 207. The performance of the 206 and 207 is a little looks similar, and for the first ID, we think there should be some bugs of their code. Yeah. Sometimes it works, but sometimes the performance is very, very bad. Yes, so this figure shows the MAE curve for the length of day. And so the team 6 and team 7 is looks much better than the first team, and also the UT1. And here we can see that with the denoised EM dataset, the prediction of both UT1 and LOD improved. Yeah, especially in the for the time span longer than 10 days. And then lastly, we evaluate the celestial power set. So here we have only 1 submission. So the right panel, left panel for X component, and right panel shows the Y component. Yeah. The Y component seems is much better than the X component, but because it's a have much longer period, maybe we need long time to see the performance. Maybe, yeah. We just put result here, and this slide shows the MAE curve for the selection power offset. Currently, we have only one summation, so we cannot compare with others. Okay, so lastly is our last section. I want to show some prospects, and I think we make evaluation and make feedback is important. And for example, as we have shown previously, the ID201, the submission seems to have some bugs because sometimes it works and sometimes it doesn't work. And recently, they have already updated their code, and the red panel shows the updated the code. The performance is getting better. This page shows performance if they use the updated code. They dramatically reduce their prediction. Yeah. So there is some prospects, and we confirm again that the AI-driven algorithm is very powerful, especially for the long-term span predictions. And we also found that it looks like the MAE curve tend to be flatter for the AI-driven algorithm. We have, I think it might be due to some loss functions. If we want to have the better performance for the EOP prediction for machine learning, we better to develop some loss functions dedicated for the EOP predictions. For example, given the higher weight for the short term, yeah, and we found there are so many AI techniques involved very quickly. So maybe several months past, there will be new neural network architectures, and I also learned some like for the LM models, they have some framework. They can easily pull the model and push the model to share the model. So if in the future for EOP prediction, we use AI technique. Maybe we can develop a workflow. We can easily just load model and make prediction and make evaluation, and then for future AI-driven EOP PC, we can update not only our prediction, but we can just push our model, and then we can compare we use exactly the same inputs. Yes, yeah. Another is we found the EOP prediction model is a data-driven model. So if we want to improve the algorithm and improve your prediction model and improve your code, you must to do like prediction and evaluation, and then just updating your code. And here I think because the prediction is data-driven, another choice is not only we make a feedback of the algorithm, and we can also try to, based on evaluation, and we can develop some algorithm to also to improve the input data set. And then we can have a better performance of the predictions, not only model, but also the data. And hopefully in the future, we can have more input data set from geophysical, yeah. So this is the last slide. I will say thank you for invitation of the AI for EOP work group to give opportunity to give a talk here. Thank you, and thanks for your attention. So I will stop here.